Okay, so I'm going to talk to you about how to graph a tan curve. So just watching, this is not in your booklet. Okay, so here's what we know about tan. Right? We all know that? Okay, that's a fact from the past. Okay, I'm going to draw you some important points on a unit circle, and you're going to tell me in 2 seconds what the tan is when I'm there. Okay, when you're in these positions on your unit circle, you know what the tan value is. Okay, ready? What is y divided by x? What's 0 divided by 1? 0. Okay. What are these numbers when you divide them? 1, because what's the same number divided by the same number? Okay. What's the value here? What's this y divided by this x value? Undefined. Can't divide by 0? What's this division going to make? -1. Okay, so you know how to get these values easy. So this is 0. This is back to dividing to be +1. This divides to undefined, and then -1. Okay? When you're doing a graph and you're graphing the value undefined, what do you look at on a graph? How do you graph undefined? Fancy word. Asymptote. Vertical asymptote. Okay, so let's do this. So where does the tan graph fall in our notes? Okay, so we at 0 was 0. And then at pi over 4, that's the root 2 over 2 root 2 over 2 coordinate. Up at the top, that's the undefined. And then we went into this quadrant, that was the negative root 2 over 2 and positive root 2 over 2. So that was the -1. Back to 0. Okay, and then I'm at +1. Back to undefined. -1. And then 0. Okay, so that's what I was doing, right? Y divided by x. Okay, so I'm going to graph these points. I'm going to go 0, 0. Pi over 4, comma 1. Asymptote. There's an asymptote there. Now I'm at -1. I'm at 0, 1, asymptote. Can you backtrack me? What's this coordinate going to be? -1. And then I'm at another asymptote. Okay, so here's what it's going to look like. Kind of like a S wave, sideways S wave kind of thing. graphically, when you have an asymptote, your graph always shoots up or flat, whatever you're doing, along it. Okay, let's go down to, well, range is the easiest, because what's the low? Negative infinity. What's the high? Infinity. Okay? So a tan graph does not have that as amplitude. We don't have an amplitude because we don't fluctuate up and down, right? Because we shoot up and down. Okay, so no amplitude. So that word for the sine and cosine will not happen here. Okay, domain. It's going to kind of have to do with our asymptotes. So let's go to our asymptotes first. X equals pi over 2 plus pi k, K-E-I. So what did I say there? I had one at pi over 2, and then if I move pi, I'm at another one. Okay, so here it is. Okay, I'm at an asymptote at pi over 2, and if I move a pi, I'm at another asymptote. If I move another pi, I'm at another asymptote. Okay, does that make sense? The first asymptote was at pi over 2, and then the next time you move pi to get to another one. Okay, so our domain is, I'm going to go x can be anything, or you could do negative infinity to positive infinity, except for the asymptotes. You can't hit the asymptotes, so we're going to just take the asymptotes. You cannot be at pi over 2 or any pi distance after that either. Okay, so this is the location of the asymptotes. So in our domain, we have to take that out of our domain. So you can write, this means the same thing. X is an element of any real number except. Okay, so now a period is repeating a cycle. So would we agree that this is a cycle of movement from here to here? Because after this asymptote, I repeat again. So I do something and then I repeat. So what is the distance it takes to go from here to here? Pi. Okay, this is pi over 2, 3 pi over 2, so it only takes me a pi and where are the zeros located? So if I look at the x-intercepts, 0, pi. The next one would be at 2 pi. So every pi k. So 0 pi, 0, at 1 pi, 2 pi. Okay, on an exam, I feel like this is the only question I've ever seen about tan graphing, is that they shift it right and left. That's the only like transformation in that ABCD stuff. I've only ever seen them shifting this graph left or right. Does that make sense, how you would do that? Okay, I've never seen a stretch. Okay, so that's kind of the only thing to think about. Okay, just flipping through, what do we have left? Well, this is just me showing you the normal. So remembering what? Sine, how does it start? Middle, upward. Cos, how does it start? On a top. What's up with tan? Tan has a bunch of asymptotes. Okay, now what do we got? Ooh, I'm going to mix a trig and an absolute value together. All right, so step one, let's graph I'm going to graph this. This is my first step. I'm just going to stretch. Can you give me a stretch on sine? I did not draw arrows. Why didn't I draw arrows? Because it told me to start at x value 0 and stop at x value 2 pi. Put a dot, not an arrow. Step 2. I'm going to take that graph and I'm going to absolute value it. So absolute value means keep what's at or above the axis. So this first mountain can stay. That mountain can stay, but we have a valley down here. It's below the axis, so instead of being below the axis, we need to make it positive. Okay, final graph. So I'm shifting that down one. Okay, you need to have a label on your x-axis and a label on your y-axis. As long as you have one of the tick marks labeled, you're good. Okay, so somebody else could have not done the 2 pi. If somebody else had pi over 2 right there, that's good. It covers the basic tick marks, okay? You have to have a minimum of one tick mark labeled. Okay, on both axes. Okay, flip the page. Bottom, minimum. Okay, so we had a minimum and then we had a maximum. Okay, you also know inside your cycle you'll also have midlines, right? Okay, so you can think about that bottom, middle, top, middle. Like that's going to be the cycle of the wave. So I want to break down heights. So here's all the things I can think about with heights. What's a top, what's a middle, what's a bottom, what's that fluctuation? So I can already tell you 150 is at the highest, 90 is at the lowest. I have to figure out what's in the middle. Do we know how to find a middle? Add them up, divide by 2. add them up, divide by 2. Okay, I got 120 in the middle, which means how much am I going above it and below it? From 120 to 150? Okay, that number better be the same. You better go the same above and then the same below. Okay, so we're going to make a sine and a cosine equation. We're going to have to do A, a B, a C, A, B, C, D. Okay, I know everything there is to know about heights. So which two of the transformation letters affect height stuff, Y stuff? A and D. A and a D are all the Y changers. That's what I can fill in. So A in the front, D in the back. What goes where? Where should I put the 120? Middle. That was a shift. So where do I put a shift? That was a shift up. What does A do? Vertically stretching. So where do I put a vertical stretch value? A position. Okay, so now let's talk about a period. Okay, so here I moved from 4 to 7. So I've gone 3 spaces, but that didn't make me go through a cycle. So can you visually see a cycle or period would be 6 spaces then? Because 4 to 7 moved 3 spaces, but I'm actually going to need to go another 3 spaces to get to the bottom again. Okay, so I'm going to use my understanding about the period. The period is 2 pi, but it can be compressed by b. So 6 equals 2 pi over, solve for b. When I solve, I can just crisscross multiply. And you can write that value in. I'm going to reduce it . So A, B, and D are all the exact same. So the only thing that's different is the C value. Okay, I'm going to go to cos because it's easier. How do you start a cos curve again? What's the normal place to start? You need to start on a top. Where does this graph start on a top? We can take that one. So we can go -7 to show that it's to the right 7. The top point is to the right 7. How do you start a sine curve? Well, that needs to be on a midline upward. So which midline does it have to be? This one or this one? Has to be this one. This midline doesn't work for sine because it's going down. What's the x value? How will you get it? What do you know about that x value? Okay, so there's 2 things I could do here. I could just say what's between 4 and 7. Okay, that's one thing I could do. Or, remember our period was 6? If you divide 6 into 4 chunks, you're moving 1 1/2, 1 1/2, 1 1/2. So 4 1.5 later, you're at 5.5. 1.5 later, you're at 7. This one would line up with 8.5. Okay? And then 10. So do you see the period covers 6? It goes from 4 to 10, 1.5, 1.5, 1.5, 1.5, or what's between 4 and 7? So subtract 5.5. Okay, make an equation here. We're going to make an equation. We're given a graph. So, can you figure out all the AD stuff for me using my little tool? I don't know, I just make this up. This gets me all my A and D values here somehow. So it looks like my top is at 4, and it looks like my bottom is at -6. Therefore, if I add, divide, my middle is at -1. Okay, I just need to talk for 5 more minutes, and I feel like I am having to yell over little side conversations here. So that's going to be my D. So how much am I fluctuating above and below that number? 5 above it or below it, which is telling me my A stretch. That's how much I'm stretching above it or below it. Okay, let's take a period. What looks easier, to go from some kind of top to top, bottom to bottom, middle to middle? Okay, it doesn't matter, so I could just grab any coordinates. So I'm going to go some random ones just so you can see it works for anything. Do you see what I've done here is this to this shows me a cycle. You can take a cycle from anywhere in your wave. Does that make sense? Because they would start repeating after I'd be through that. So how long did it take me to travel through there if I started on the 6 line and I'm ending on the 12 line? I went from 6 to 12, so that means my period is 6. Okay, so here we go. Y equals, I'm going to put 5 Okay, so we got that stuff done. The midline shift, the stretch apart, the change in the period. Okay, so here's my question. What looks easier to find points for X values? Do you like finding coasts, top points? Do they line up nicely? Or middle lines? Do they add up? Which falls on a nice number? Midlines, okay? Because this top value here, I don't know. It's not really lining up on a point, right? So pick me a midline. You have to be on a middle and you have to be heading in an upward pattern. So not 6, that doesn't work. There's lots of options. 9, So x minus 9 would work. So I'm going to go with sine x minus 9. I could have also picked 3. Do you understand that every sixth number, it would work, right? Because every sixth number, you see another one of those points again. So what would be 6 more after 9? At 15, right? 21. Okay, there's lots of options, okay? I also see another option here. This is kind of tricky, but what if I wanted to just start on this line? How would I change something here? Does anybody know? If I wanted to start middle heading down in an equation, what could I just change in my equation? Negative sign. Right? So that's another option. I could have just wrote negative sign, and then I wouldn't even had any c value now because it's at 0. Okay, 2 more questions and then we're done. Okay, a rock gets stuck in a car tire and the car tire is 24 inches. Okay, so I'm a visual person, so here we go. There's my tire. And if a rock is inserted into your tire, where would it be starting from? The ground. Okay, the rock will go, somebody in my applied put like it's starting over here, okay? It's not a flying rock, it's just gonna be on the road. Who's a car person? When you say you have a 24-inch tire, does that mean a radius or diameter of the tire? How do you measure tires? Diameter. Okay, so my diameter is... So let's talk about heights. What do I always do? I do this. What's the height fluctuations? So what's the lowest position of the rock? 0. What's the tallest, the highest? 24. So where would it be when it's in the middle? 12. How much fluctuation is going above and below? 12. So when I create a graph, I'm going to be starting at a height 0, and then it's going to go to the height of 12, right there. The rock's going to go there, and then the rock's going to go to the top. Then the rock's going to go to the other side, and then it's going to go back to the bottom. So 12, 24. Why did I draw one arrow and one not arrow? Because it's time and we're starting at 0 time. We're not backing in time. Okay. So now it says this. It takes 6 seconds for the wheel to go around. So this is 6 seconds. So what are all the increments of these 4 positions? So take 6 divided by 4. Okay, so an equation, I'm going to go plus 12, that's the middle shift, I'm going to put 12 in the front because that's our stretch as well. We just did this one above. Is that okay if I just copy down? We just did a period of 6. Pi over 3. Are you okay if I just write that in there? We just did the exact same thing. And it says, write a sinusoidal equation. So when you write a sinusoidal, it can be sine or cos. A sinusoidal means anything that's going like a wave. So cos and sine are two of the ones that do wave. Tan is not sinusoidal because it doesn't go up and down like a wave. You can do either one. You pick. If you do sine, you better shift it 1.5, example. And if you do cos, you better shift it 3. Or you could do no shift, but it would have to be a negative cos. If you did no shift, it's a negative cos then, if you wanted to do that. Okay, again, equation stuff, lots of options. Okay, this is always on the exam, something like this. And it's like 1 point and nobody gets it. Okay, so okay, so here we go. I've graphed this equation, so it's already been done. And now, how would you solve this? Okay, so first of all, tell me what happened from here to here. What's the only difference you see from this to this? -1 is representing the y. So from here to here, the only difference is now the y is a number, -1. So where would the solutions be to this equaling this? Where y is -1. So where do you ever see that? There would be an answer. There would be an answer. There would be lots of different angles as answers. Okay, I'm just going to give you a sample of why everybody gets this wrong. I don't know what this x value is. I'm just going to make it up. So if this was a coordinate, for example, 0.6, -1, I just made this up. Okay, here's what I get as the answer. 0.6, -1. I have to give you 0 points. That is not an answer. How would I correct that? So think about you. If you were to solve this algebraically, what would you write at the end of this algebra? X equals. You're solving for the angle x. So if you wrote x equals 0.6, that would have been an answer. Does that make sense? I don't want to write a coordinate because the solution of this would be solving for an x value. So the solution is what x value works to get me that -1. So that's what you're thinking about. The solution on graphs, what x value gets me that y. Not You don't write a point. The point is not the solution. The point is the intersection which will provide me the solution. Because I'm trying to think about where's the x that is getting me to the -1 height. Okay? Remind me I should talk about that right before your exam, because that's almost always something of that concept on an exam